Howdy, AP PreCAL, it's Ms. Kosh. Here comes the third of today's problems. I'm using, I modeled my FRQ problems off of stuff I've seen out there, so hopefully this will give us an idea of what it looks like. But I decided if I wrote the problem, I can make my own video and that sort of stuff. So go look in the link, the information in this video. Hopefully I'm giving you a link to this PDF. So you can try this first and then come back and watch me. Okay, so on a particular windy day, a buoy on Grapevine Lake, which is one of my favorites, it's very close to where I live and where I teach. A buoy on Grapevine Lake takes 3 seconds to oscillate up and down. The buoy is 25 feet above the lake bed when it's at its maximum height and 17 feet above the lake bed. I guess that's a real word, anyway, whatever. But the floor, the bottom of the lake, however you want to say that, when it's at its minimum height. Okay, a sinusoidal function models the distance between the buoy and the lake bed in feet as a function of t in seconds. Okay, so now they've given us 2 full periods, so they've started here. They've given us 2 periods of this. There's no scale. This, I think we are guaranteed to see something like this on the AP exam. And I copied their verbiage. Okay, so let me come to the one here. So response 4. Okay, I would, if it were me, I would label this one, and then I would probably indicate underneath this the information they ask for. Okay, so they tell us it takes 3 seconds to oscillate up and down. Notice it does not tell me where time is 0. So I don't see any reason I can't put 0 wherever I want it to be. I would probably just use these points. I would say, okay, let's start at time 0. Let's make this time at 3 seconds. Okay, so it's done 1 full oscillation. It oscillates up and down. Takes 3 seconds to oscillate up and down. Okay, it's 25 feet above the lake bed up here. So then that's where it gets back to 25. And then it's as low as, well, halfway between 0 and 3 is 1.5. And how low were we? We were 17 feet above the lake bed at its minimum. Okay, so what is this? A difference of 8. So from 4, if I go down 4, I'm at 21. And then halfway between 0 and 1.5 is 0.75, so 0.75 seconds. And this is 21 feet above. And so we're at 0.75, we're at 1.5, we're at 2.25. And then this, oh, that's too many 2's, my bad. There's the 5 now. Okay, sorry. Comma, we're back to this height of 21, and then we get there at 3. Okay, so because it's messy, I'm sorry, maybe we should go ahead and label F is the point 0.25, G is the point 0.75, comma 21, J is 1.5, comma 17, K, our favorite letter, 2.25, comma 21, and P is 3, comma 25. That, I think, is what we would do. Let's verify. 5 points, no scale is indicated, no axis represented, determine possible coordinates for the 5 points. It looks like I did what they asked. Okay? Continuing on, now we still need this page. Then they tell us that we can write it as a sine function. Okay, so notice they're asking us, it has to be sine. What I would have honestly done, based on the way I graph this, is I would write it as a cosine. But they say, no, write it as a sine, so you're like, oh, okay. Because this is sinusoidal and because it's periodic, we have lots of correct answers for this sort of thing. Notice what I could do is I could back this up and say that this is the point. If this was 0.75, then this would come back to negative 0.75, comma 21. This, and then, so then we add 0.75 and we add 0.75 and we add 0.75 and keep going. So this point could help us. So here's my point. I see a sine curve that starts here at this point that's not on the curve. I see a sine curve that starts here. I see a sine curve that has a negative. So there's lots of options on this one. So let's see, on B, they're telling us, so B of t would equal the amplitude. Well, what was the amplitude? A is the amplitude. So how high up did I go? From the midline to the top was 4. And then, so sine of, okay, now I also need to figure out the B value. Well, the b value comes from the fact that it's 2 pi over b is equal to this period of 3. And so therefore b would be equal to 2 pi over 3. 2 pi over 3. Oh, so they have parentheses here and parentheses here. This one's not required, but they put it here, so maybe we should do that. T plus, okay, now if I want to move it to the left, it becomes a plus. So plus 0.75. And then how much did I move up? Where is my midline? My midline is at 21. If you're thinking, what the heck are you doing, Ms. Kosh? Go back and watch my videos on trig curves and all this kind of stuff. I probably have a whole unit doing this sort of thing. I think this answer is perfectly acceptable. So maybe we should say that A is equal to 4, that B is equal to 2 pi over 3, that C is equal to 0.75, and that D is equal to 21. But we could write this other ways. I could, like, this I think is a perfectly acceptable answer, and we're done. You could have also said that this is a negative 4 sine of the 2 pi over 3 won't change ever. If I do a negative, that means that I've come this way. And so to shift it to the right, it becomes a t minus 0.75 plus 21. And so now my c value is negative here. My a would be negative, so those two would have changed. Or you could tell me 4 sine of 2 pi over 3 times t, and then the plus 21. Notice the only way that the amplitude is going to change, well, okay, let's say this. The absolute value of A will never change. The amplitude is the amplitude, but it could be positive or negative depending on which part I start with. The period gives us the B value, and that won't change no matter what happens. The midline gives us this, how much it's shifted up or down, and so that's not going to change. But this one, I was thinking of using this value right here, and so if I want to shift it to the right, I have to make this a negative 2.25. Okay, so that's really all you need, but I was being overly generous or confusing. Sorry. Okay, let's see. So now it says refer to the graph of B in part A. The t-coordinate of F is T1. So F is T1. And the t-coordinate of G is T2. That's here. On this interval, so we're looking at this little piece right here. On the interval, what is true about B? B are the y values. The y values, everything's positive. So if you remember what we graphed, the smallest value we ever see is a positive 17. So negative is no good. I mean, what's happening? Well, those t values, I lied. Those b values are positive, but they are decreasing. So I would say B. I think that seems like a reasonable way to answer that question. Describe how the rate of change of B is changing on that interval. This is concave down. Whenever it's concave down, the average rate of change is decreasing. So the average rate of change is decreasing on the okay. That is FRQ 3. Come back for my 4th video where we work through FRQ 4. Like, subscribe, comment below. Let me know how I can help you. Let me know if you see that I did anything wrong. Say it nicely, though. No, just kidding. Well, I mean, yes, be kind, especially if you don't know me. Okay. No, even if you know me, everybody be kind. Goodbye. Go practice. Good luck.